Alright class, here's part 2 of section 5.7. What we're going to look at right now is we're going to look at this guy called René Descartes, French mathematician, found a relationship between the coefficients of a polynomial and the number of positive and negative zeros of a polynomial. So what we need to know is this right here. If you have some function 2x squared plus 5x minus 1, some function, to find out how many positive real zeros that it could have, all you have to do is look at the number of sign changes right here. How many times did it change the sign of the coefficient? And then you have to take off 2 from whatever number you got if the number is high enough. So look at my function right here. 2x squared plus 5x minus 1. This is a positive 2x squared. If I look at this sign of this coefficient, that's positive, and I look at the next sign, that's also positive. There's no sign change. Okay, so now I go from this sign, which is positive, to the next sign, which is negative, which means I have one sign change. Okay, what that means is I have one positive real zero in this right here. So if you actually type this in to your calculator, you would see this thing cross the x-axis on the positive side just once. Okay, that's what that means. Now let's look at the number of negative real zeros. How do you find the number of negative real zeros? Well, to find the positive ones, you have to look at f of positive x right here. That's what this was. F of positive x equals this. To find out how many negative real zeros there are, you have to look at f of negative x. And this is the tricky part for most people right here. So, how do you find f of negative x? F of negative x is equal to, well, look at this up above. If I'm going based on this example, okay, if I put negative x instead of x, this would become 2 times negative x squared. If I put a negative x here, that becomes plus 5 times negative x, and that's it, minus 1. Let's kind of simplify this. 2 times negative x squared. Negative x squared just becomes x squared, right? That's still 2x squared. This becomes minus 5x, then minus 1. Notice the only thing different about this than this up here. The only thing different is this minus sign. So, how did that minus sign occur? Based off of this x to the first power, this changed the sign. So since negative x was plugged in here, it changed the sign from positive to negative. But because negative x was put right here, it didn't change the sign. Why didn't it change the sign? Because it was squared. So there's a little trick to this. If you have x to the fourth, it would stay the same. Right? X to the sixth, this thing would stay the same sign. But if you have x to the third power, it would change signs from positive to negative, so on and so on. Let me show you what that means in this next problem. So let's finish it. How many negative real zeros could you have? Well, let's look at the sign changes. This is positive 2x squared, so positive to a negative, there's one sign change. A negative to a negative, there's no change here. So there's only one sign change from here to here. So this means, since there's one sign change, that means there is one negative real zero in this thing right here. Okay? So there's one positive zero and there's one negative 0. Those are your answers to this question. Now let's use this rule of signs on the next problem. Okay? It's going to be a little more complex. Now it's x to the 6th power. Okay? Make sure everything's in order. X is 6, 5th, 4th, so on, so on, so on. All you have to do is tell me how many positive real zeros there are, how many negative real zeros, and from those answers you'll be able to tell me how many imaginary zeros there are. So pay attention. All you have to do is this. Count the sign changes. But you have to do that for, number one, you have to do that for f of x, which is right here. F of x is this. Count the sign changes. Okay, this is positive. Positive to a minus. There's one sign change. Minus to a plus. There's another sign change. A plus to a minus. There's another sign change. A minus to a minus. No sign change. A minus to a minus. No sign change. A minus to a minus. No sign change. So what you found here is there are 3 sign changes. What does that mean? That means there could be, see how it says possible? There could be 3 positive real zeros. But there's another part to this that you have to pay attention to. If you look back at that rule of signs that you just saw in the last slide, it said there could be less than this by a factor of 2. So here's what you could do. Here's what you have to do. You have to take whatever number you get. We got 3 in this case. 1, 2, 3. And we have to subtract 2 from it, which gives us 1. So it could be 3 positive real zeros or 1 positive real zero. We don't know. We don't know for sure. This guy just found this way just to tell us how many possibilities we could have. We could have 3 or 1. That's what you have to write. You could write it like this: 3 or 1 positive real zeros. What if you got the number 5? Let's say what if. What if you got 5 sign changes up here? Well, then you'd subtract 2. You'd get 3 sign changes. But you'd have to subtract 2 again and get 1. So if the answer was 5, if you could say there could be 5, 3, or 1 positive real zeros. But that's not the answer to this. Here's your answer: 3 or 1 positive real zeros. I'm just giving you an example. You always have to subtract 2. Now, if you subtracted 2 from this one, you'd get negative 1. You can't have negative 1 real zeros. That doesn't make sense. You always subtract until you get 1 or until you get 0 as an answer. Okay? Alright. That's how many positive real zeros you could get. Alright, to recap, how do you find the number of positive real zeros? You look at f of positive x, and you look at all the sign changes, right? You count them, and then you take 2 off, okay? Now, let's look at the number of negative real zeros. So, which means we have to look at f of negative x. Now, f of negative x, all you really are doing is putting negative x where you see an x. So negative x here, so on, so on, so on. and I'll do that for the moment, but I'll show you a little shortcut here. I want you to see why, or the shortcut won't make sense. Negative x to the 6, not just x to the 6, minus 2, negative x to the 5th, plus 3, negative x to the 4th, minus 10, negative x cubed, minus 6, negative x squared, minus 8, negative x. And minus 8. Now look what happens. When you do negative x to the 6th power, that's a negative 6 times, which is a positive x to the 6th. Notice that f of x is x to the 6th, and f of negative x is also x to the 6th. It did not change. Next, negative x to the 5th, well, negative 5 times is still negative. So that's negative 2 times a negative x. So that becomes a positive 2x to the 5th. That one did change, right? That was negative 2x to the 5th. Now it becomes positive 2x to the 5th. Next one. When you do negative x to the 4th, that's 4 times, which makes it positive. So that's 3x to the positive 4. Notice it did not change from here to here. Notice what's changing and what's not changing. Down here, negative x cubed, that does change. So negative 10, and then you got a negative left over. That makes it positive 10x cubed. Over here, negative x squared, that doesn't change it. Well, negative x squared is x squared, right? So this becomes negative 6x squared, and this becomes negative 8 and negative x, which makes it positive 8x. And you've got minus 8 on the end. Notice the things that changed. This was negative 2x to the fifth, but this was positive. This was negative 10x cubed, now it's positive. This was negative 8x, now it's positive. Notice what changed? X to the fifth, x to the third, x to the first. All the odd exponents changed. The even ones, notice, negative 6x squared, negative 6x squared. All the even exponents stayed the same. So the shortcut is doing this. You don't have to type in negative x every time and then solve it like this, put it in here like this. All you have to do is say, okay, that's a 5, so that negative 2 becomes a positive 2. That's a 3, that's a negative 10, so that becomes a positive 10. And that's a 1, so that's negative 8, which becomes, switch it, positive 8. Okay? That's the trick to finding f of negative x. Now, we have to use f of negative x, and all we have to do is count the sign changes. Let's count. Here we go. That's a positive to a positive, no sign change. Positive to a positive, none. Positive to a positive, no sign change. Positive to a negative, there's one. A negative to a positive, there's another one. A positive to a negative, there's another one. So this becomes 3 sign changes, which means there could be 3 negative real zeros. Or you could say 3 or 1 negative real zeros. Remember, we're just finding how many possibilities there could be. There could be 3 negative zeros, or there could be 1 negative zero. We don't know until we would put it in the calculator. But that's not what this question is about. It's all about finding possibilities. Why'd I get to 1? Remember, you have to subtract 2 off of whatever number you get. Okay? Let's say this happened. Let's say you counted 1, 2, 3, 4. So you write this number down. Oh, there could be 4 negative real zeros. But you have to subtract 2, right? So subtract 2, you get 2. And then you would subtract 2 again and get 0. This last number that you always write down is either going to be 0 or 1. Okay? You're going to subtract 2 from whatever number you get until you get down to 0 or 1. Okay? 4, 2, or 0. If your number was 4, you would have said 4, 2, or 0 negative real zeros. Now here comes the little bit tricky part. How many imaginary zeros could you have? Well, we said we could have 3 or 1 positive zeros. We could have 3 or 1 negative zeros. So how do you find the imaginary? Let's make a little chart. Okay? So, we're going to make a chart. I'm going to say positive, negative, and imaginary. Okay? So positive in one column, negative in another column, and imaginary in a third column. Then we're going to have total zeros. Now what you should be able to fill in right now would be how many total zeros are there for this whole function. If you look at this, it should be 6. Okay? Should be 6 total zeros. Now, how many positive did we say we could have? We said 3 or 1. How many negative? We said 3 or 1. That's the only thing you can put in these columns. 3 or 1 in this column, 3 or 1 in this column, and that'll determine how many imaginary we could get. Let's say we had 3 positive based on that number. 3 positive. Let's say we had, look it up here, 3 negative, right? How many imaginary could there be? Well, if there was 3 positive, 3 negative, the total is 6. There couldn't be any imaginary because it'd be 3 positive zeros, 3 negative zeros. There had to be 0 imaginary. Total of 6. You see how it all adds up to the total amount of zeros. Next, there could be 1 positive. Right here, I'm getting that from. There could be 1 or 3 here. You just have to choose one. We'll just go with 3. Could be 1 positive, 3 negative, which means how many imaginary could I have? They all have to add up to 6. So it could be 2 imaginary. Right? Basically, this thing is just finding all your possibilities. That's all it is. What else could we have? We could have 3 positive, like here, And how about 1 negative, which would make 4 total zeros right now, which would mean there'd be 2 imaginary left over. So 3 plus 1 plus 2, 6 total. And what else could we have? We could have 1 positive. We could have 1 negative, which would mean that's only 2 down. We still need 4 more zeros, which would have to be all imaginary to make a total of 6 total zeros. Okay, let's see. So we cover all of our possibilities. 3, so 3 and 3, 3 and 1. Got it. 1 and 3, 1 and 1. Got it. Covered all of our possibilities. So how many, so last question, how many imaginary zeros could you have? Look at this column. You could have 0, could have 2, or you could have 4 imaginary zeros. Answer. This imaginary zeros, 3 or 1 positive, real, and 3 or 1 negative, real. There you go. Basically this is your answer right here. Or I guess you could give me this chart if you really wanted to, but either case you have to tell me this or this. Okay? That's example 4, Descartes Rule of Signs. Make sure you understand this. Try one for practice. We'll practice on your own. Just check this one real quick. How many sign changes do you see for f of positive x? Here's positive to positive. There's none, and there's 1. So there could be 1 positive. You don't take 2 off. You can't do that. It's the lowest it can go is 1 or 0. Next, how many negative? Well, you have to do f of negative x to give me negative. Change the odd. That's positive, so now it's negative x cubed. This is odd degree as well, so that becomes, instead of positive, negative 2x, and you leave that minus 11. How many sign changes do you see? Negative, 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 negative. You don't see any sign changes, so here's what we say. 0, negative, real zeros. Okay? 1 positive real could have, 0 negative real could have, and then you have to use that to figure out how many imaginary zeros you can get. So you can make a little chart, positive, negative, imaginary, and make sure you have the total. So the total is 3. So positive could be 1, negative there could be 0. So imaginary there has to be 1 plus 0 plus 2 gives you a total of 3. And that's all you could do. You have no other options. You can only put 1 for positive. You have no other option. You can only put 0 for negative. No other option. So this is the only instance that you can have. Okay? So you would say 1 positive, 0 negative, and 2 imaginary. Alright? That's your answer. Right there. Okay. Next one. That was an easy one. Alright? The next one is a little longer. You do this one, then I'll show you the answer. Go ahead, pause the video. Alright, here's your answer. Positive. You counted 4 sign changes, which subtract 2, you get 2. Subtract 2 again, you get 0. So 4, 2, or 0, positive. Negative, you didn't get any sign changes. Okay, that's it. Imaginary, you put it all in that chart. If you put this many, all your options in there, you should get 4, 2, or 0 imaginary. Okay, so that's how you do Descartes Rule of Signs. Figure out how many possible positive, negative, and imaginary zeros there could be for a function. Now, example 5, we're going to approximate, which we have actually already done in class, basically. So, all you're going to do to approximate is find the decimal form, right? Is plug this in your calculator, this big long thing. Okay, and I'll just show you the next slide. Now when you plug it in your calculator, you're going to see this. All you're going to do is you're going to find this one. I taught you how to find that using your second calculate 0 button. So it's going to give you this answer right here. Actually, this one's going to give you this answer right here. Then you go get this one. So that's what they did over here. They went and got this one, and they got this answer. Notice those numbers. This is an irrational answer. But this problem is not about getting the exact answer. This problem is all about approximating. So as soon as it says approximate, you can use your calculator and approximate the zeros that you see in the graph. So you can round it to a couple decimal places like 2.73 and negative 0.73. There's your two zeros that you find in the calculator, which you've already done. So that's it for that question. Very simple and easy. You've done it before. Alright, which brings us to our last problem. And here it is. Last one. Tachometer. Tachometer measures speed. For a certain boat, the speed x of the engine shaft is in RPMs. S of the boat in miles per hour. The speed of the boat is in miles per hour. So, speed of the boat is here. X is the RPMs. So, what is the tachometer reading when the boat travels 15 miles per hour? So, what are they giving you when they say 15 miles per hour? Well, miles per hour is the S. So, you got to put in 15 right here. Right? You put in 15, and then you make it equal to 0. Then you subtract 15 from both sides. So, you substitute 15 into the equation, and then what they did was they made it equal to 0 after they had 15 in for S of x. Okay? Now, I got this right here. So how can you find, it said, find the tachometer reading, meaning find x. Find x when the y was 15. All you have to do is use your calculator. This is like example number 5. You're going to approximate what the RPMs are, what the x is based on the calculator. So all you're going to do is find the 0 right here. So if you type that in your calculator and you say second calculate 0, you should get this answer right here. So what does that answer tell you about 19.9 what? Well, you have to go back to the question. 19.9, those was hundreds. X was in hundreds, so 19.9 hundred, which means this many RPMs. So be able to take a word problem, type it in the calculator, make it equal to 0 first, and then be able to find x based on the calculator. So sometimes you can approximate, but most of the time I want you to find the exact answer. Okay? So, you guys can do your homework. You can work in pairs if you're quiet and teaching each other. Yep, just have a good rest of your day.